Okay, so hello guys. So welcome to another problem solving session with Special Maths Academy. So Obukume Ejaife here, and today we're looking at problem 5 from the recently conducted PAMO 2023 edition, and it's an algebra problem. It says to find, okay, it says let A and B be real numbers with A not equals to 0. Then let P of x be ax 4 to power 4 minus 4ax to power 3 plus 5a plus bx squared minus 4bx plus b. They were to show that all roots of P of x are real and positive if and only if A is equals to B. Yeah, so there are some things I would want us to take note of. The first is the if and only if condition. Basically this if and only if condition makes this a problem, a two-directional problem. That means we have to prove two things, two directions. So I'm going to write that out. So first of all, there are two directions. Um so let's start with okay, say suppose um the roots are P, Q, R, S, right? Then they said that to show that means we have to show that this set of roots PQROS are positive reals if and only if A equals to B. So this means two things. So we'll first show one direction on direction one. Um PQROS being real implies this. Then for direction two, we'll show that A equals B implies that PQRS are all positive rules. So let's go with the first direction. Okay, so let's go with the first direction. So I'm going to go with the first direction now. So I'm going to use this Vietes formulas now. So this roots concept. So over here, let me just come here. I'm going to like put a formula here now. So in case you're not so familiar with what Vietes formula is like. So Vietes formula says that assuming you have like a polynomial p of x, okay, and p of x is supposing it has coefficients. Yes, a1. I'm going to just state it for like this case, a1 x to the power 4 plus a2 x to the power 3 plus a3 x squared plus a4 x plus a5. We know a5 is a constant term. Then Vieta's formula is saying that p plus the sum of, and the roots here are pqrs. pqrs are roots of p of x. Then what Vieta's formula is saying is this, that Vieta's formula is basically saying that p plus q plus r plus s is minus a2 over a1. So it starts with a minus sign, like this coefficient of x cube is a2, so it's minus a2 over a1. Then when you take the roots two at a time, that is pq plus pr plus ps plus qr plus qs plus rs, this is like a3 over a1. So this was first one was minus, second one is plus. Then when you take them three at a time, it's pqr plus pqs plus qrs plus prs, yeah, equals minus a4 over a1. So you can see it's alternating between minus, plus, minus. Then the last one is just pqrs. When you take the 4 at a time, it's only just one, so that's like a5 over a1. So this is like the Vieta's formulas. So we can call this 1, 2, 3, and 4. right? So this is like VHS formulas. Okay, so let me just um, show them here. Okay, so this is like the last one then and all that. So this is not really okay, so this is just like a theorem in case you don't know what VHS formulas are before. So because we just need this, we're going to use this theorem to solve this problem. So with that theorem, if we compare this P of X with this our coefficient here, then we can automatically see that if we compare with our initial problem, we have that A1 is A2 is um minus 4A, um okay, A2 is minus 4A, okay. So we have A2 as minus 4A. What is this topic? Okay, A2 as minus 4A. A3 is 5A plus B. That's the coefficient of x squared in this case. A4 is minus 4B. And A5 is just B. So if we use that, so let me scroll down. So yeah, if we use that, so if we use that now, we have something like this. Okay, so we have that P plus Q plus R plus S. We said is minus A2 over A1, which in this case will now be minus 4A over over A, which is okay, minus 4A, sorry. Let me clean this. So this is equals to minus, then A2 was minus 4A over A, which is 4A over 4, minus minus becomes plus 4A over A, which is 4. Then you have that PQ. Okay, let me use another color now. PQ plus PR plus PS plus QR plus QS plus RS is equals to, we know it's the first one was minus, the second one should be plus. It's A3 over A1, which is 5A plus B over A. Our A, which is like 5 plus B over A, right? When you simplify, then 4 at a time, it's 3 at a time, rather, is PQR plus PQS plus QRS plus PRS. And this is going to have a minus because it's minus plus minus, which is minus 4B over A, which is 4B over A. Then the last one is PQRS, which is A5 over A1, which is basically just B over A. So you can see what we are using here. See the coefficients here. So I just plug in this. So this is like the VHS identities for all the for the conditions you have. So let's state some ground rules now. I think we need some ground rules like going forward. I think that would help. So what do I mean by ground rules? Yeah, so what are positive real numbers? I think that would be a good place to start from. Because going forward we're going to use that definition. So if a positive real number, okay, let's go down. Let's go to the left. A positive real number cannot involve zero. I think we're okay with this. So so PQRS being positive reals, implies that none of PQROS is equals to 0, right? Because 0 is not a positive real number. And it also means that, and okay, so it also means that roots P, roots Q, roots R, and roots S exist. They are also, yeah, they exist. I think this part is very important. This will come in handy soon. You will see why. So let's manipulate these four equations now. This is, let's call this 1, 2, 3, 4, right? So we have this four, whatever. So we can manipulate. What do I mean by that? So let's just, that from equation 4 we have PQROS is equals to B over A, right? So you can substitute B over PQROS for B over A in equation 3, right? You can substitute that. So if we substitute B over A for PQRS in 3, then we'll have that. So let me come here now and make the substitutions. So I'm coming with this now. So this is the equation I'm working with. Let me use it. Let me box this. Okay. Yeah. So this is like the equation 3 I'm talking about. So if I substitute PQRS for B over A, so I have something like PQ arrow plus PQS plus Q arrow S plus P arrow S. We know this is equals to 4B over A. And we know that B over A is PQ arrow S, right? Then I can divide through by PQ arrow S. Why can I do this? Because none of PQ arrow S is 0 because they are positive rules. We agreed on this. It's very important. You'll see why soon, because this we need to write it like this. So I divide through so that I have that 1 over, so when I divide through I have 1 over S plus 1 over arrow plus 1 over P plus 1 over Q is equals to 4. So let me box this. This is a very, very important result. Let me just bring it somewhere around here. I'm going to come back to this. So we have that okay, one, okay, so we have something like 1 over S plus 1 over arrow plus 1 over P plus 1 over Q equals to 4. And also remember that PQ arrow S, they are greater than 0. This is very important. This is very important, and yeah, none of them is equals to 0. You'll see why soon. So come back to equation 1 now. See equation 1 here. Let me use the one in blue. So you can see equation 1 here. This one. Let me use yellow this time. So this is equation 1. Okay, so from equation 1, you will recall that we had PQRS as 4, right? P plus Q plus RS is equals to 4 from equation 1. So from 1, so from equation 1, P plus Q plus RS plus R plus S equals 4. And we also know that 1 over S plus 1 over R plus 1 over P plus 1 over Q equals 4. So one thing I would say is so now this is where things become this thing. So we know PQRS are positive, they are all positive, we are going to this. So we're going to need an inequality here, and I'm going to show you how we're going to force the equality case. So this is the characteristic squares inequality. I'm sure this is like a common inequality in Olympiads, and it states that so let's just put Cauchy squares here in case you don't know what Cauchy squares is. It states that for two sequence of real numbers, um real numbers a1, a2, an, this is one sequence, and b1, b2, bn. On that sequence, we have this inequality to be true. We have that a1 we have that a1 squared plus a2 squared plus dot 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 plus an squared. Okay, we have this times b1 squared plus b2 squared plus dot 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 plus bn squared is greater than or equals to okay then equals to a1 b1 plus a2 b2 plus dot 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 plus an bn all squared. And equality holds both the left hand side is equal to the right hand side when a1 over b1 is equals to a2 over b2 equals to a3 over b3 and so on and so forth onto an over bn. So this inequality is going to come in handy. Why? So I'll show why now. So we're going to use this Cauchy squares inequality now. So we can say so first of all we just need we can say since p is since so that is where this comes in. So you recall that PQRS, they are positive root greater than 0, right? That means root P, root Q, root R, and root S, they actually exist. They are also real numbers. So we can plug, so let's say, suppose you say A1 is equals to root P, A2 root Q, A3 root R, and A4 as root S, right? Then we can also repeat the same thing here. We can say let's B1 be 1, let B1 be 1 over root P, let B2 be 1 over root Q, let B3 be 1 over root R, and let B4 be 1 over root S, right? So we plug this into this equality now. So if we plug into the, then we know that from Cauchy squares, so from Cauchy squares, or from just Cauchy basically, we know that A1 square, which is, we know that A1 square is P, A2 square is Q, A3 square is R, A4 square is S, then B1 square is now 1 over square root of P all square, which is 1 over P. Similarly, we have this as 1 over Q, 1 over R plus 1 over S. We know this is greater than or equals to. So A1 times B1 is root P times 1 over root P, which is 1. A2 times B2 is root Q times 1 over root Q. So just see what's going on here. A1 times B1 is root P times 1 over root P, which is 1. So we have okay, let's do something else here. We have A2 times B2 is root Q times 1 over root Q. which also equals 1. So that's just where these ones are coming from. So you can do the same thing. So you have this greater than 1 plus 1 plus 1 plus 1 all squared, right? Which is like 16. So this is like, we have that. This means that P plus Q plus R plus S into 1 over P plus 1 over Q plus 1 over R plus 1 over S is greater than 16, right? But you know that we have this. Now you now recall that P plus Q plus R plus S is 4. And we also know this is equals to 4, right? So this is 4 times 4. So this is actually 16. We have 16 greater than equals to 16. So this means that since these two sides are equal, it means equality holds in this case. Equality holds, right? So that means we have the left hand side is 16. The left hand side is equals to 16. Um Left hand side equals 16 and right hand side is also 16. So we know the left hand side of the inequality equals right hand side. That means equality holds in these Cauchy squares. And we said that in Cauchy squares, if equality holds, then if equality holds, then recall we said that means A1 over B1 equals to, I can zoom it out so you can see it. Okay, let me zoom it in a little. Okay. So remember we said if equality holds, then we know that A1 over B1 is equals to A2 over B2 equals A3 over B3 equals A4 over B4, right? So A1 over B1 is like this. So let's see. So A1 over B1 implies that um root P divided by 1 over root P. This is A1 over B1, and it is equals to A2 over B2, which is root Q divided by 1 over root Q, and which is the same thing as root arrow divided by 1 over root arrow, which is equals to root S divided by 1 over root S, right? So so far so good. So then you can, like, when you simplify, this means that this changes to root P times root P over 1, which is equals to P. So this can simplify to become P, and this simplifies to become Q. So we have P equals Q equals arrow equals S. So this is very important. So it means that P equals Q equals arrow equals S, right? So we've gotten that P, and this means that we know that P plus Q plus arrow plus S is 4, right? So it means that since they are all equal, means we can write this as P plus P plus P plus P equals 4. That is 4P equals 4, and that means P equals 1, right? So we have that all the four roots of the equation now are all 1. So we have the four roots are 1. But that's not what we actually wanted to do. So if you remember, I wanted to show that so if you come back to the initial first case, let me zoom in. If we come back to see what we wanted to do, so we know what PQRS is now. So we're like almost there, at least for the first direction. So see where we were at. So we wanted to show that if PQRS are positive rows, then A equals to B, right? So we'll show that, first of all, what we've shown is this. Let me show you what we've shown now. Take this part out. We don't need this part. Mhm. So, so we first of all shown that, okay, so we've shown that PQROS. So this is what we've done so far. We've shown that PQROS being positive reals implies that PQROS are all one, right? One, 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 one. So next thing we'll now come back and plug. We'll now say, okay, if PQROS are one, so you now come to equation 3, you now say, okay, fine, we know what PQROS has to satisfy this equation. So from equation 3 now, from 3, see equation 3 here, the one I boxed in green earlier, this one. So you can see 3 here, equation 3. So from 3, we know that PQRO plus PQS plus QRS plus PRS equals 4B over E, right? But we know that PQ, R, and S are all 1, 1, 1. So this is just equals to 1, equals to 1, equals to 1, equals to 1. So this is 1 plus 1 plus 1 4 times, which is 4, equals 4B over A. And this means that B over A is equals to 1, right? When you divide both sides by 4. And this implies that B equals A, which is what we wanted to actually show, because we have now shown that, fine, that, okay, so we've compared the first part, we have shown that PQRS being positive rules, we've manipulated using VATs, and we got that means that PQRS is 1, all of them are 1. And so that when all of them are 1, we see that B over A equals 1, which implies B equals to A. So that's like the first direction is basically done. So we've completed the first part. To me, that was actually the difficult part, because the second part is really, really easy. So for the second part, this is what you just do. So to make the second part go away as fast as it can. So remember the second direction was this. So now come to direction 2. That A equals B implies that PQRS are positive rows. So let's come to that. So you just write your P of X out again. We know P of X is, I think it was AX to the power 4 minus 4AX cubed plus, I think it should be 5A plus B X squared. Okay, go up. Okay, 5A plus BX squared minus 4BX plus B. Okay, minus 4BX plus B, right? So we'll just take that out a little. So minus 4BX plus B. So if A equals B, we can just plug in. If A equals B, then means P of X is AX4 minus 4AX cubed plus A equals B, this is 6AX squared minus A equals B, this will become 4AX plus A, right? And I can bring out A out. I'll have something like x to the power 4 minus 4x cubed plus xx squared minus 4x plus 1. So if you're very observant, this is basically just equals to x minus 1 to the power 4. Yeah. So we have that P of x is A into x minus 1 to the power 4. And the roots of this, the roots when P of x equals 0, then means A into x minus 1 to the power 4 equals 0. And that means this is x equals to 1 4 times. So the four roots are now, the roots are just 1, 1, 1, and 1. 1 4 times, like multiplicity of 4. So which is actually true, because, and this implies this, because 1 is a positive real number. So, and with that, we've completed it. So we've shown that when A equals to B, the four roots are 1, 1, 1, 1s, and that's like the end of the second phase of the proof. So let me write it out. So when A equals B, the roots PQRS is equals to 1 1 1 1, which are all positive reals, and this completes direction 2. So completed these two parts. So with that, we've come to the end of this video. So it wasn't a really difficult problem. I think the key fact was using Cauchy squares. I would say the difficult thing here was actually just knowing how to make the inequality case common, like using this Cauchy squares part. I think this yellow part. I think this part was really key. So this was the key part actually. Hmm, Let me highlight it. So this was the key parts. Because once, if you see, the first direction was actually more difficult to prove, because once we showed that this had to be equal, once we showed that P equals Q equals arrow equals S, once we establish that P equals Q equals arrow equals S equals 1, the rest actually followed very easily. Like we just had to like manipulate and all that. So we've come to the end of this problem solving session. It was nice having you guys around. So still stick around. There are still more videos coming up. So that's all for now. Bye, and do interact with us on social media, and share this video to help more students who may be interested in math Olympiads. I'm coming from Special Maths, and that's all for now.